Welcome to Chem 207's Lab Number 2, Determination of Ka. Today we will be titrating acetic acid with sodium hydroxide in order to determine the acid dissociation equilibrium constant. You will need the following supplies: vinegar or 5 to 6% acetic acid, distilled water, 0.5 molar sodium hydroxide, phenolphthalein indicator, and some glassware such as a 100 milliliter beaker, 25 milliliter or 50 milliliter graduated cylinder, a 25 milliliter volumetric pipette with a rubber bulb, Kim wipes, a 150 milliliter beaker with a stirring bar, a hot plate with magnetic stirring capabilities, a 50 milliliter burette with some sort of clamp such as a 3-finger clamp or a Buret clamp, a Buret funnel, and a large waste beaker such as a 600 milliliter beaker, a pH meter with a pH probe, and pH 4 and pH 7 buffer solutions to calibrate the pH meter. Let's get started. First, I will be making the acid solution for titration. I have poured out a random amount of vinegar into a 100 milliliter beaker so that I can pipette out 25 milliliters for the titration. The way that you would pipette is to take the rubber bowl and just draw up the liquid into the pipette. Let go slowly, because when it reaches the wide part of the pipette, it can take longer to suction up the liquid. The point is to get enough liquid in there and allow it to rise a little bit above the calibration line. Take off the bulb and then use your finger to slowly let the liquid go down. Kind of like when you're drinking soda with a straw and you use your thumb to control the amount of liquid going in and out of the straw. This part you should do carefully, because once it goes up into the top part, it will flow much faster and can get caught inside of the bulb. Make sure there are no air bubbles. Otherwise, you will not get the correct volumetric reading. Slowly let your finger go to control the flow. Read the volume at eye level and hold on tightly when you want to Stop and then transfer the amount to the 150 milliliter beaker. As that flows down, we can start to prepare about 25 milliliters of distilled water to go inside this same beaker. It's only an approximate amount, as the acid will react directly with the base. Okay, I have measured out about 25 milliliters. And now we'll add 3 drops of the phenolphthalein indicator. Now you are ready to stir. So turn on your hot plate and allow the magnetic stirring bar to do the stirring for you. Keep it low, about 200 RPMs or lower. I will show you how to rinse the burette next, and then how to set up the pH meter for the titration. Let's rinse the burette to prepare it for the experiment. Grab your 50 milliliter burette and make sure that the stopcock is closed or horizontal. You'll need a 50 milliliter burette for this because the titration will require a significant amount of volume. Also, make sure to have a burette funnel at the top of your burette to help you with pouring the base inside. So I already have a little bit of base in there from a previous titration, so I'm going to discard it into a waste beaker and re-rinse my burette for this titration. So making sure that the stopcock is closed, I'm going to grab my 0.5 molar sodium hydroxide solution. I'm going to insert the burette funnel at the top of the burette and pour about 5 milliliters of sodium hydroxide solution into the burette. Now I'm going to remove the funnel and twist as I pour out the sodium hydroxide, just so all of the surfaces inside the burette have been rinsed with sodium hydroxide. I'm going to pour again some more sodium hydroxide. This is quite important to do if you have just received some supplies for your lab. Never assume that the glassware has been cleaned before you. It is clean for the most part, but sometimes it can have a little bit of residue, or it has too much water inside, and you do not want that to skew the concentration of your sodium hydroxide. Okay? I like to do one more so that the tip can be rinsed. So let's add a little more. And then putting the burette over the waste beaker, open the stopcock and let the sodium hydroxide drain down. This will ensure that whatever liquid or water or particles were inside of your tip will be rinsed down. Okay, once it has drained, close the stopcock and you are ready to refill your burette completely to the top mark. So for this experiment, we will fill the whole burette to the 0 mark on the top. Fill it a little bit above the 0 line. Take out your funnel. position your burette on the stand. Leave a little bit of room for the waste beaker underneath. Make sure the numbers are facing you so that you are ready to read. And we're going to drain some of the excess that is above the zero line into this beaker. So do a little at a time. And since this is a very tall burette, you can remove it to check at eye level and see how much more you need to drain. So I'm going to use the counter now to help me with the drain. And it looks like we are at 0. Okay. So our acid is prepared. The base has just been prepared. Next, we will reposition the pH meter for optimum pH reading. Okay, so I'm going to place my acid under the burette, and this is just so that I can position everything the way that I want it before everything will be used for the experiment. So right now I have the pH probe in a buffer 7 solution, pH 7. So I'm going to remove the probe from the solution, rinse it with distilled water. Luckily the buffer solutions are colored so you can tell when the pH probe has been rinsed of all of the buffer. Use a couple of Kim wipes to help you dry the probe before you put it into a new solution. And particularly dab the tip of the probe so that all of the drops of water are dried up. So now the pH probe has to go inside of the acid solution, as we will be reading the change in pH of this solution as the base drops. And I will show you a front view of the setup as well. So kind of play around with your setup. Make sure that the pH probe is not touching the wall of the beaker and that it's not touching the stirring bar as it moves. So you can turn on your stirring bar to see where the stirring will occur, and then place your pH probe inside of the liquid a little bit to the side of the stirring bar. It sounds like the stirring bar is hitting the wall, so I'm going to adjust my beaker. Okay, perfect. And also make sure that your burette has a clear shot inside of the beaker and that you can read the lines so that you don't have to adjust anything during the procedure. Okay, so I have my pH meter here and I can tell the reading. I will bring the camera a little bit closer so that the setup is more clear. Okay, so we're back here with the main setup of the titration. I have my pH meter ready to measure, and I have my pH probe inside of the acid indicator solution. I have my stirring bar ready to go, and I have the burette that we just prepped. The instructions say to add 1 milliliter of 0.5 molar sodium hydroxide to the acid solution at a time. You will start by recording the initial volume or the initial sodium hydroxide that you have added. So to start, we have added nothing. So your first point would be 0 milliliters. We have to read the pH of the starting solution when we have added no sodium hydroxide. So let's read the pH. It looks like the pH is 2.41. Okay, so you would record that as your first point. I'm going to add the first milliliter of sodium hydroxide. Alright, so wait a few seconds before getting the pH reading. And since this is your first addition of sodium hydroxide, the second point would be 1 milliliter total of sodium hydroxide added, and then we will find out the pH momentarily. The pH after 1 milliliter addition is 2.75. This is how the titration will go. You will add 1 milliliter increment and then record the pH. I'll show you a couple of more additions and pH readings. But for the sake of time and the video, I will fast forward until the point where the end point is almost reached, and then show you what that looks like. The pH after adding 2 milliliters of sodium hydroxide is 3.04. Let's add another milliliter. Okay? And as you record the data, make sure you are reading the volume on the burette to the nearest 0.01 milliliter. So for example, you would write down 2.00 if it's exactly on the line, or you would write down 9.11, for example, if it is at 9.1 but a little bit lower than the actual line. It is quite important to estimate the best guess for the volume on the burette so that you can get the best results in your plot. Okay, we can read the pH. 3.24. Let's add another milliliter. At the beginning of a titration, perhaps the first 5 to 8 milliliters of volume, you can add a little bit faster than the rest of the volume. That is because since it is early on in the titration, it is highly unlikely that the endpoint will be reached so soon. Let's read the pH. .39. Okay. Let's add one more. I have already done one trial of this titration off camera, so I already know where the endpoint is located. After reading this pH, I will go ahead and add most of the volume, and then I will come back and show you the endpoint area. Before skipping to the endpoint area, I need to read the pH so that you can see the change at this moment. It is 3.52, and the data is coinciding very well with the previous titration that I already did off camera. So we're on a good track. Welcome back to the titration. I have added sodium hydroxide up to the 40 milliliter Buret line of volume, and I have not read the pH yet, but I decided to wait until the stirring took place for about a minute or two, just to make sure that all of the sudden addition of sodium hydroxide was well incorporated into the acetic solution. So let's read the pH after the addition of 40 milliliters. .67. I obtained 5.71 in a previous titration, so that is quite close. I will now add another milliliter to the solution, and now it is close to the end point, so I will try to be as careful as possible, but I know sometimes the Buret might go a little bit off than we'd like. I'm at 41 milliliters right now, and we'll allow it to stir a few seconds before reading the pH. I will read the pH. 5.83. Okay. I'm going to add a couple more drops. And I will try to reposition the camera so that the Buret and setup can be seen without my arm in the way. So I will be right back. I have zoomed you into the beaker for these last additions. Hopefully you can see the beaker. With every drop you could see that a little bit of pink from the indicator is showing. So even though you have to add 1 milliliter at a time, it's much more important for you to be paying attention to the liquid and seeing if there is a pink color that is persistent and doesn't go away with continued stirring. When this occurs, you will know that you have found your endpoint. I will return when I have added a few more volume. I have added up to 42 milliliters of sodium hydroxide. Since the endpoint is right around the corner, I'm going to read the pH. And the pH is around 6.14. Okay. Now I will add a little bit more. 1 drop at a time. I will zoom you in. And we are still clear. Titrations can be a tedious process to get great results, but the effort is totally worth it. I think the first trial is always the most time consuming just because you don't know exactly where the endpoint will be. But after that, the next couple of trials are always a breeze because you know that the endpoint will be at a certain volume, and you can sometimes go ahead and add close to the endpoint and then be extra careful as you get to the endpoint site. Of course, you don't want to do that if you're collecting points for a graph. You can't simply add the volume and not collect points. So just keep that in mind when doing this experiment and take your time. Aha. I believe we have found the endpoint. Let's see if you can tell there's a pinkish hue. There it is, pinkish hue. And we should record the volume that we have dispensed. So we are at 43.3 milliliters. And we will give the pH reading. When you see the faintest first sign of pink that doesn't go away, that's when you have reached the end point. Alright, so after letting everything incorporate well, we have a pH of 8.23 as the end point. There's a very faint pink color inside of our beaker, and as I said, if you go and take your time, you will reach just the exact end point that you need, and you will not overshoot it. If it is a vibrant pink color, you have added too much, and you will see results that are above the Ka that you are looking for. Well, we have come to the end of Lab 2. Thanks for joining.